Hi guys, welcome to Paper of the Week, or MDE Paper of the Week should I say. For this paper we chosen a fairly small paper to make sure that we can do this fairly quickly. We always do this at the end of the week and we're always a little bit tired by the time we get to the paper of the week. So it's hard to have a 35-page paper to read at this point in time. But nonetheless, it's actually an interesting paper because one thing to keep in mind is that with Mars we're trying to create a sort of methodology, and because of that we need to have a quick look at how people have done methodologies around MDE and other variations. So this paper is called the Lightweight MDSD Process Applied in Small Projects, and MDSD is just basically Model-Driven Software Development, one of the many acronyms that you find for MDE. So let's just get cracking, I think. So the abstract of the paper: model-driven software development, domain-specific languages and other generative programming approaches have gained much attention. Okay, this is always quite relative, but there is a large number of tools available, starting from simple code generators to full-blown tool suites. Some of the problems I always have with model-driven engineering is that we're never quite sure exactly what belongs to model-driven engineering or not. I mean, is a simple code generator really a model-driven engineering tool? There are several success stories. Actually, it might be worthwhile getting one of our lovely Control-C, Control-H and adding range of tooling in MDE is vast. It's never quite clear how one decides if a tool is part of MDE or not. So in other words, it's important to see if there is some kind of, I think that people tend to claim everything is part of MDE as long as it's got some kind of relation to models. And I think it's important to see that, if you've just written a code generator and you've got no idea how MDE works, and it's not entirely clear if that should really be considered MDE. So we'll just leave this as a note, probably to fill it in later on. There are several success stories and process frameworks about applying full-scale MDSD approaches, but there is no or little help for small-sized projects. To fill in this gap, we designed a new development process which targets small and middle-sized projects with limited resources. Okay, so that's interesting, really. We probably want to really highlight this bit here, because this is the same niche that we always have that color problem. Change page and change back again, and then we can change that to green. Okay, so something similar here. Target is small projects. Similar to Mars, the target of this paper is small and middle-sized projects with, let's put autofill mode on, limited resourcing. Okay. According to our experience, the process is working efficiently in small projects, even if they cannot afford bigger initial resource investments. Okay. And this, well, to be honest, we're going to end up highlighting every single line here of this abstract of ours. In this experience report, we document an industrial project in which the process was used. We present this process in the form which is applied in the first project, and also discuss our experience and the limitations of the process. Okie doke. So we see here that this is an experience report. We also see that it's mainly focused on agile and software processes. So they're not really introducing the methodology in a overly formal way. They're just letting us know what they've done, sort of more of an empirical approach. So in this paper we describe a new lightweight model-driven software development process applied in small development projects. We kept from the general MDSD methodology just those parts that are needed for small projects. Okay, interesting. We combine those parts of the MDSD project and an iterative software development process to our new process. According to our experience, this new process is working efficiently in small projects, even if they are sensitive to the initial cost factor. The major contribution of this experience report is to document that and to which extent it was possible to apply such a process in an industrial project. We described the process as it was applied in the first project, and also discussed the lessons from it. Most of the resources available for practitioners is focused on the technological aspects. So this is quite an important thing, and it's very true. There's a very big focus on just the technology and not really focusing on the application. Books about this topic also give no or little hint about how MDSD could be integrated. Let's have a quick look before we progress. Let's just look at 3 and 2, make sure that we cover those already. As it happens, we have got this somewhere, but not this chap here. So I think we should probably copy this and perhaps if we just meta I, and if we put a note here saying papers to read, or bibliography perhaps, and we just add this chap here. And now let's just resume where we were. Also give no or little hint about how MDSD can be integrated into the software development process. The process you've mentioned is explained in the context of technological steps. On the other side, several proposed methodologies target enterprise environments with sophisticated customizable methodologies. Case studies like 10 even explicitly state that the MDA technologies are appropriate only for large organizations. Very important. I would change color, but we know that there is a bug somewhere. Certain agile practitioners are of the same opinion. So let's have a quick look at 10 and 11 again. So, introducing MDA in a large IT consultancy organization, and Pound Counterpoint Handler is one of our favorite authors, should I say. I think we probably will add this chap here. I mean, time is not infinite, sadly, but it's worthwhile keeping a few of these things to check. Future reference. We have not found anything closer to our approach. To successfully apply, so of course this is a 2009 paper, there's plenty of lightweight things going on right now, but we just chosen this one because we had read this paper before. So to successfully apply a new approach in a project, there are several other factors to be considered that are independent from the theoretical soundness of the approach. Its learning curve, its ability to special requirements, its adaptability to special requirements, and the maturity of the supporting tools are probably the most crucial properties. So presumably we can just say this is probably just a yellow, I guess. Important success factors. Learning curve, probably should quote to make sure that we know that it's not ours. And maturity of the supporting tools. 3 good points there. We're aiming to give a solution with the following pragmatics. We explicitly support the initial partial usage of MDSD, i.e. So this is very important for us. We generate the code just for the concepts in the domain model where it pays off. Otherwise, features are programmed in the traditional way. The advantage of this solution is that the domain model can be easily kept focused and abstract. So that's exactly our approach as well. Creating our own MDSD tool using an existing language saves the license and learning investment of a new tool and transformation language. Using open source software may eliminate the license costs. The mismatch between the capability of the tool and the requirements of the user introduce further cost factors. According to our experience in small projects, these costs outweigh the extra cost factors that arise from building their tools. Okay, all of these factors are quite relevant, really. And we build the MDSD tools iteratively, which means that each new requirement in the project may lead to new requirements in the MDSD infrastructure. I am very tempted to highlight all of this, quite sadly. Bit excessive, I guess, but these 3 points are really important. So I'm just gonna pink all these guys out. So the pragmatic approach, let's just put some notes here. Pragmatic approach. Similar to MDSD, the authors decide to take on a pragmatic approach. It's spell. Chaka didn't seem to have helped us with the following key factors: partial usage, create a tool rather than use an existing one due to cost factors. These include open source tools. That's a very good point there. And then finally, iterative approach to building a tool. Okay, in the following section, we outline the project context and our approach to solve the stated problem. Then we describe in detail the process we built on top of the existing method used by the project team. Finally, we conclude our experience in the lessons learned. So a bit of project background. Our customer needed MDSD process tool to support the deliver a web application for a specific domain. First author participated in the project as a consultant and contributed to the development of the MDSD infrastructure to understand what kind of challenges appear. Obviously, this is a preprint. Appear in such type of industrial projects. The deliverable application had to be built on top of Microsoft's ASP.NET 2.0 and a MS SQL 2000 backend. It's obviously slightly dated, but it also had to conform to existing architecture guidelines for the multi-layer enterprise ASP.NET applications at that time. Readable source code and complete development documentation was also a must because the end customer intended to extend and maintain the delivered application in-house. Project team carrying through the project was used to a traditional iterative development method which contained elements from current agile methodologies but did not conform to any of them exactly. This is very standard in industry really. Informally, the requirement was to generate code from a model similar to the code generated by built-in wizards. This is clearly the usual sort of setup. The point is to allow code generation without human interaction, even in the case of... okay, so perhaps let's just get rid of that note, and then the point is to allow code generation without human interaction, even in the case of model changes to speed up the development of the simple parts of the application. I prefer this bit here, actually. The requirements to the model-driven software development approach we had to deliver were as follows. Most of the risks should be mitigated. The technology should not be based on immature tools, and the introduction of the technology should always leave open the possibility to fall back on traditional methodology without MDSD tools. Okay, very important point. The approach should not delay the schedule in general. It should have immediate business advantage. The approach should be cost sensitive. The purchase of high-cost MDE tool set and extensive training for experts are not possible. The domain model should be kept simple as possible, and the generated code should be human readable and modifiable. The results should be reusable in other projects. So really, if you think about it, these requirements here are really crucial to pretty much anyone involved in a small application of MDSD. The reusability, well, makes sense, but so we probably should just come back to our node and say requirements. They require for this project are actually quite general. Risk mitigation by allowing so we have a risk mitigation by allowing the use of traditional development if MDE is found to be problematic. This is kind of the typical sort of problem we always have. So no extra time allowed to develop MDE tools. So costs is an important factor, and training is limited. And code should be human readable and modifiable. So this is really important set of requirements. So the process. In our process we distinguish two different phases, the initial phase and the development phase. The development phase contains many iterations. Figure 1 gives an overview of the process. The diagram shows the initial phase and the first two, well actually, first probably should just highlight this chap here. And we should, because these are quite important, go for perhaps green. I think this could be green because we've already used pink for something slightly more important than this. So this is middle importance. Figure 1 gives an overview of the process. The diagram shows the initial phase and the first two iteration phases. Presenting the iterative phase twice in the diagram makes it possible to show the connection between them. The artifacts are represented by boxes and the activities are represented by ellipses. So let's have a quick look at the diagram before we continue. So we have an initial phase, there's a bit of design going on here. The inputs to that design process are the software requirement specification. It's not very agile, but it's fine. Clearly we have a business analyst team. And then of course you can see here there's a model-driven development team on one side, there's a typical software development team on the other. The guys in the model-driven team are trying to extract a domain and obtaining some kind of model-driven MDE vision and creating a domain model. And the chaps at the other side are trying to create things by hand. And then the idea is that these chaps here are going to start to deliver stuff in terms of the domain model. And the guys here are going to start to integrate the stuff that these guys are delivering over here to the integration phase. And then they start coding. So you see this is basically a dual track development system whereby model-driven development is taking one track and the rest of the team is developing regular software. They integrate via these integration points. Now this is not the approach that we propose for Dogen. We should really make a good case for this. But this is very, very important. So figure 1 gives an overview of the process. So we already covered bits of this. So shading of the shapes means that they are parts of the original development process. An arrow can connect an activity to an artifact or an artifact to an activity, which means that the activity produces the artifact or the artifact, using the activity respectively. The flowchart is divided by dashed lines into 3 swim lanes. The swim lanes represent 3 different internal teams. So there you go. There's the BAs, the dev team, and the MDE team. The horizontal position of the activity is explained which internal teams they belong to. If an activity or an artifact is positioned between 2 swim lanes, then there is a joint effort 2 teams. Under the term internal team, we just mean a group of people who have focus on a certain type of work. Okay, these internal teams are communicating heavily with each other and have the overview of the whole project. So now let's just talk a little bit about the teams. The Agile development team was responsible for development of all non-generated software functionality which is not represented in the main model. So I don't particularly agree with this, but there you go. The business analyst team was responsible to keep in touch with the customer and was also responsible for the requirements in the domain models. And finally, the model-driven software development team was responsible for the development of the MDSD environment and the templates. So the vertical axis in figure 1 denotes the time, so time is going downwards, and the horizontal line represents the borders of the phases. The figure shows the initial phase in 2 iterations such that the connections between the phases are depicted. Vertical positions of the objects express how they are related in time. The arrows also provide information about dependency of 2 actions. If 2 objects are connected and they have the same vertical position, they follow each other immediately. Several artifacts were created and maintained during the project. We emphasize the following 2. The functions of further artifacts follow clearly from the description of the process or used according to the common sense. So an MDSD vision is a document containing the strategic decisions detailed in MDSD. It specifies which aspects of the requirements are implemented with MDSD technology. So this is interesting. It also prescribes the abstraction level of the domain and its scope. Well, I'm going to highlight this. For now, just stick with yellow. A domain test model is a special model which serves as a test for the generation process. It is an artificial created small model with good meta-model coverage. Well, everyone does this, of course. With Dogen we call these reference implementations. It is used by the developers and does not represent any real-life model. Not entirely sure if this is worth highlighting, but it's a shame I haven't got a third color for meh, I guess. Important, but not overly important. No, we do have dark gray, I guess. Might not be a very good highlighting color. Yeah, probably not the best. Let's choose something else. Perhaps something like what is the middle of the range highlights? Well, the yellow is probably enough, I guess. Let's just go back. I can't even choose yellow. We have to find yellow first. We also define 3 activities which need to be clarified to make the understanding of the process easier. So the MDSD environment setup is activity when the code generation tool is set up according to the MDSD vision and the initial domain model. As part of this activity, the initial version of the domain model, meta model, and the domain test model are created. Okay. The template development is the activity by which the templates are extended and refined. This activity usually happens in 3 steps. The required functionality is implemented in software prototype, the implementation is extracted and inserted into the templates. Finally, they are tested with the help of the domain test model. So this is very, very different from what we do. Integration is the activity by which the generated code and uncrafted software are merged. So let's just put a note here. Activities. The approach is a traditional dual track development model with a separation of the MDE team from the main team and using integration points to join the work. MD MAS is very different in that we intend to back out the MD part of the work by empirical analysis of existing codes. So this is probably worthwhile keeping in mind. So integration is, as we mentioned, integration is activity by which the generation code and then are merged. After the merge, integration test is carried out. So the remaining terms are used in their usual sense. The reader may find the full definition in 14. So now let's just get to the meat of it. The initial phase. The process is started with initial phase. There are 3 groups of activities in this phase. The business analysts team and the MDSD team extracted the main model by joint effort. So this is a very clear separation of MDE from the development team. Domain experts from the customers are also contributed. The Agile development team elaborated the architecture of the software. By the end of the initial phase, they shipped a sufficiently stable prototype to the MDSD team, which started to develop templates. This is always very worrying because, of course, you're working from a prototype. The MDSD team set up the initial version of the code-generated core. The team was also familiar with the technology environment used by the Agile team. And took over the architecture from the prototypes. By the end of the initial phase, we had the first version of the domain model represented in Excel spreadsheets, an informal description of the domain meta model, a working version of the code generator tool, and part of the domain model as a domain test model. Our customers successfully used the first generated code to demonstrate to the end customer the navigation structure of the application. Then we entered development proper. During an iteration of the development phase, the following activities were carried through in parallel. The business analyst team refined and extended the domain model. The changes to the domain model did not affect the developers, so the model could be changed until code generation activity started. The team kept in touch with the customer. Its responsibility was to handle change requests of the requirements. The Agile development team developed the non-generated part of the software. The customization of the generated parts and the integration of the custom components were also the responsibility of this team. So this is very, very sort of separate way of doing things. We have a team in a splendid isolation doing one thing and another team in splendid isolation doing something else, and we rely on integration. This is a little bit dangerous really, but so make sure the highlight looks correct. In the end of this iteration, this team received the generated artifacts and carried through the integration. There were always cases where the newly generated artifacts needed minor modifications or interface mismatches had to be corrected. As expected, to ensure the successful integration, also integration tests and regression tests were performed. Critical bugs were corrected during the integration, and the whole activity was repeated. The MDSD development team was busy with the template development and the MDSD environment development. In the end of this iteration, the team produced generated artifacts on the domain model with the help of the latest MDSD development and templates. Enhancement of the MDSD environment was usually orthogonal to the template development. The template development was the most complex and critical activity of the process. Okay, let's give a highlight to that. Typically, for an iteration of the process, several features were planned to be implemented iteratively in the frame of this activity. The implementation of a feature started with its design. Then the feature was coded and tested. During the implementation, the generated development artifacts were extracted. Now this is very important. So development process. So I would say MD development process. Crucially, development process is driven by the MD team using how should we phrase this? So as you can imagine, if you're a development team and you're trying to an MD development team, you're trying to imagine what the use case is going to be. You need to use some kind of how should I put this? You need to create some kind of use case for the feature you're developing. We could probably say so. Typically, for an iteration, several features are planned to be implemented. The implementation of a feature started with its design, and the feature was coded and tested. So crucially, the development process is driven by the MDE development process is driven by the MDE team. They work off of prototypes. They develop and then deliver features to the Agile team, which provides feedback. The problem with this approach is that the features do not need to be grounded on the needs of the Agile team and can be speculative. This is the danger of this approach, is that the MDE team can go off on its own little world where things are perfect, and then the Agile team then is not very happy with what they deliver. So the generated development artifacts were parts of the runnable application, which was generated by the latest version of the templates of the code generation tool and the domain test model. The implemented feature was extracted from the source code and inserted into the templates with necessary modifications. Okay, have we missed something here? The template development was not typically for the iteration process. Several features. The implementation of a feature started with design, then the feature was coded and tested. During the implementation, yes, exactly. So what we're saying is that the MDE team would code the feature manually first, test it, and then implement the templates from it. Whereas what we suggest is that the Agile team should code the feature. So that's fine. The generated development artifacts were recreated by the modified templates. That's fine. The result typically contained small errors which were detected when the result was built and tested. Test was carried out with, so we do like the fact that they are backing out the templates, the artifacts from the templates. So we should say template development. It is positive that templates are attempting to recreate code that was manually crafted, as this is a very good sanity check. So that is good. We'll probably put that before the bibliography. Templates were modified until no errors occurred during the test of generated development artifacts. Then the feature was considered complete and the team moved on to implement the next one. Okay, so let's just look at the conclusions quickly. Model-driven software developments. Look at how long we're taking. Half an hour, so it's not too bad. So model-driven software development and domain-specific languages are active research areas, both for the academic and the industrial communities. In this paper, we have described the lightweight process which was successfully applied in industrial projects. We provide a comprehensive description for the minor details which need to be understood for real-world projects. So this is our 14. Perhaps we should add this to our list of things to possibly read. Though I think we've got the gist of what's going on here. It's probably not necessary, and it's probably behind some kind of paywall. Our approach is not only usable for small and mid-sized projects, but can also be used as a preparatory step before the introduction of a heavy MDSD approach. Okay, I like that. Our project was considered by our customers successful in comparison with previous agile projects. However, it was not clear how to evaluate the project objectively. This is a very difficult thing in MDE. It may be judged according to basic project metrics, but there are no such data available from similar projects. According to the project culture of the company, no formal size estimation was carried through before the development, and the project metric was also recorded barely. We're not very good at recording. Here we just include these metrics, which were considered trustworthy according to internal project communication. In the final release, the total amount of source code developed was approximately 300k. This contained about 200k of lines of generated code, which was okay. So about 100k manual, 200 generated, which was produced from 0.9 lines of XML by 5. Oh wow, we have 5k lines of XSLT. The project team had 8 members, and the net effort to complete the project was around 25 man-months. There were only minor issues that went wrong during the project, but we managed to fix them in time. At the end of our project, we also experienced the limitations of our approach. Okay, this is very interesting. We think that it does not scale further without dealing with the problem of manual merging of the different versions of artifacts. Okay, very important. Automated merging support is needed for those situations in which it is not possible to keep the number of these artifacts low. Unfortunately, there is not much research documented in the literature on merging artifacts on different abstraction levels. This problem is also still an open issue in most of the state-of-the-art tools. Seem to have somehow managed to change our. So I disagree slightly with this, but we'll highlight it anyway. Let's go for a greenie. New transformation languages and tool suites will definitely ease the MDSD, but it needs to be evaluated to what extent. We We found several issues that need further investigation, like semantics of merging artifacts or optimization of test procedures. Currently, we are investigating the application of formal methods in this area. Okay, so this is the paper. I think one important thing to notice here is that, okay, this is clearly a 2009 paper, so of course you have to bear that in mind. But nevertheless, I think this is extremely common to most projects. Most people tend to develop tools by themselves. Most people tend to find MDSD or MDE, as we call it now, as they went along. And one of the papers we write is exactly about this. It is very difficult to really get your head around the whole of MDE before you can start doing anything. So because of that, everyone reinvents the wheel. Although having said that, there's a lot of interesting points that are given here with this paper, so it's definitely worthwhile reading the paper. Okay, thanks very much for bearing with us and watching it.